This is the Professor, CBMD PhD, and today's Thursday, May 25th, 2023. It is 10:05 and 39 seconds, p.m. Eastern Daylight Time, and today's research, Holographic Universe. So let's jump to it here. How many dimensions in the Holographic Universe? Date February 9th, 2009. Source: Vienna University of Technology. As scientists are trying to understand the mysteries of the holographic principle, how many dimensions are there in our universe? Some of the world's brightest minds are carrying out research in this area and still have not succeeded so far in creating a unified theory of quantum gravitation. Is often considered to be the holy grail of modern science. New research can now at least unravel some of the mysteries of quantum gravitational. The results on black holes and gravitational waves are pretty mind-boggling. We perceive the space around us as three-dimensional. According to Einstein, time-space are inseparable linked. Adding the time axis to our dimensional space makes our space-time continuum four-dimensional. And for decades, scientists have been wondering about the existence of additional dimensions so far hidden to our senses. Researchers are trying the opposite approach. Instead of postulating additional dimensions, they believe that our universe could in fact be described by less than four dimensions. A hologram, as you find it on black notes or credit cards, appears to show a three-dimensional picture, even though in fact it is just two-dimensional. In such a case, reality has fewer dimensions than we would think it appears to have. And this holographic principle plays an important role in the physics of space-time. Instead of creating a theory of gravity in all the time and space dimensions, one can formulate a new quantum theory with one fewer spatial dimension. And that way a 3D theory of gravitation turns into a 2D quantum theory in which gravity does not appear anymore. Still, this quantum theory correctly predicts phenomena like black holes or gravitational waves. The question, how many dimensions our world really has, does probably not even have a proper answer. Probably cannot be answered explicitly, depending on the particular question we are trying to answer. Either one, the approaches may turn out to be more useful. Researchers are currently working on gravitational theories, which include two spatial dimensions and one time dimension. They can be mapped onto a two-dimensional gravitationalist quantum theory. As such theories can be used to describe rapidly rotating black holes or cosmic strings, space-time defects, which probably appeared shortly after the Big Bang. And this is a professor, astrophysicist of advanced mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.